Exponents product rule. 4 examples with increasing difficulty. Let's break them down. First example, the product rule states if you have the same base and they're multiplying, we can add the exponents. Notice the base will stay the same. 2 plus 5 is 7. Let's make it a little bit trickier with variables and numbers out front, or coefficients. Mentally separate your variables and coefficients as they're going to do different things. Coefficients will just multiply, and your variables will follow the same rule where we're going to add the exponents together. 2 times -3 is -6, and x to the 2 plus 3 becomes x to the 5. So -6 x to the 5 is our final answer. Here's our third example. Remember to separate the coefficients, and variables are only going to combine with the same variable. So x's with x's and y's with y's. Our coefficients will just multiply, so this becomes 7 times 3. Our two x terms will combine, and if your variable doesn't have an exponent, there's always an invisible 1. So our 2x's from the first term and our 1x from the second term will add together. And since there's no other group for y's, that's just going to come down. And now we can simplify our pieces. 7 times 3 is 21. X to the 2 plus 1 is x to the 3. And our y to the 5 doesn't have anything to combine with, so we bring it straight down. And there's your final answer. And that brings us to our last example. Again, separate your coefficients, your x's, your y's, and your z's. Coefficients will multiply, and our variables will add the exponents. Remember, there's always an invisible 1. 2 x's and 1 x, 3 y's and 6 y's, and 2 z's with 2 z's. Now simplify each of these terms. 5 times -4 is -20. X to the 2 plus 1 is x to the 3. Y to the 3 plus 6 is y to the 9. And z to the 2 plus 2 is z to the 4. Smash them all together, and there's your final answer. And there you go. I hope that all made sense. Thanks for watching, and follow for more examples.